My topic is ID3 Decision Tree Algorithm. So first of all, what are decision trees? So the decision tree is a structure that contains nodes and edges. Nodes represent rectangular boxes and edges are represented as arrows. And this is built from a dataset. This dataset may be a table of columns representing features or attributes, and rows corresponds to records. Each node is either used to make a decision or to represent an outcome. So the node which is used to make a decision is known as decision node, and the node which is used to represent an outcome is known as leaf node. So this is an example of a decision tree. This decision tree is used to classify whether a person is fit or unfit. The decisions nodes here are questions like, is the person less than 30 years of age? Does the person eat junk? Etc. And the leaves are one of the two possible outcomes like fit and unfit. By looking at this decision tree, we can make the following decisions. Like if a person is less than 30 years of age and doesn't eat junk food, then he is fit. If a person is less than 30 years of age and eats junk food, then he is unfit, and so on. So the initial node is called the root node, which are colored in blue. The final nodes are called the leaf nodes, which are colored in green. And rest of the nodes are called intermediate or internal nodes. So the root and intermediate nodes represents the decisions, while the leaf nodes represent the outcomes. So in briefly we can say that ID3 stands for Iterative Dichotomizer 3, and it is named such because the algorithm iteratively dichotomizes, that is divides features into two or more groups at each step. So this algorithm was invented by Rose Quinlan, and this uses a top-down greedy approach to build a decision tree. So in simple words we can say that the top-down approach means that we start building the tree from the top, and the greedy approach means that at each iteration we select the best feature at the present moment to create a node. So generally ID3 is mostly used for classification problems with nominal features only. So ID3 algorithm selects the best feature at each step while building a decision tree. And we have a new term which is known as information gain. It calculates the reduction in the entropy and measures how well a given feature separates or classifies the target classes. And the feature with the highest information gain is selected as the best one. So the entropy means it is the measure of disorder, and the entropy of a dataset is the measure of disorder in the target feature of the dataset. In the case of binary classification, entropy is 0 if all values in the target column are homogeneous, that is similar, and it will be 1 if the target column has equal number of values for both the classes. If we note our dataset as S, entropy is calculated with this equation. Here n is known as the total number of classes in target column, and pi, it stands for probability of class I, or ratio of rows with class I in the target column to number of rows in the dataset. So we calculate the entropy in a dataset by using this formula or equation. And information gain for a feature column A is calculated with this equation using the entropy. So here SV is the set of rows in S for which the feature column A has value V. Here S is the dataset, and SV is the number of rows in SV, and likewise it is the number of rows in S. These are the 4 steps by doing the ID3 algorithm. The first is the selection of the attributes that will become nodes of the decision tree, and next step, once the attribute selected for the current node, the child nodes are generated, one for each possible value of the selected attribute. Then the examples are then partitioned using the possible values of this attribute, and these partitioned subsets of the examples are assigned to the appropriate child node. So the steps 1 to 3 are repeated for each child node until all examples associated with the node are either all positive or all negative. So by considering the sample training data given here, we can determine whether an animal lays eggs. The training dataset consists of 6 samples having 4 attributes, namely warm-blooded, feathers, fur, and swim, and we need to find out whether an animal lays eggs. So this is the dataset. First we need to calculate the entropy. So we are using the decision values in the sample set S, and we need to calculate the entropy of S. So we see that of the 6 samples, we have 4 samples are for yes and 2 for no. Hence the entropy is calculated as given here. And now we need to find the decision values associated with each of the 4 attributes in order to find the entropy corresponding to the subset for that attribute. From this we can find the gain. So we are finding the entropy of S, and we found out that for warm-blooded we have 5 yes and 1 no, feathers 3 yes and 3 no, and for fur we have 1 yes and 5 no, swims 2 yes and 4 no. And using this equation we are finding the gain value. So here we are going to find the information gain for all the 4 attributes, that are warm-blooded, feathers, fur, and swim. So as we can see, first we are finding the gain value for attribute warm-blooded, where 4 y's and 2 no's, and we got the value as 0.10916. Then we are calculating the gain value for the attribute feather. Here we have 4 y's and 2 no's, and we got the gain value as 0.45914. Next we got the gain value for attribute fur, which is 0.3167, and for swim value we got 0.4411. So as we see in here, we have calculated the gain value for the 4 attributes. At first we've found the gain value for warm-blooded and feathers in the slide, and we know that the set has 4 yes and 2 no, and we have calculated the entropy and found the gain value as 0.10916, and similarly we found gain value for feathers, fur, and swim. Now we are going to compare the gain of 4 attributes, and from these 4 attributes we can see that the gain value of feathers is the maximum, so it is considered as the root node of the decision tree. So if we are constructing a decision tree, we know that first we want to select the root node. So through these steps we found out that feathers got the highest information gain value, so we are choosing feathers as the root node. So studying the part of the table with feathers, we see that knowing that feathers as Y, we see that the animals like ostrich, raven, and albatross lay eggs without checking any other attribute. So however, for the case of feathers with N, we are not able to determine whether the animals lays eggs. For this we need to discover the reduced table and calculate the corresponding entropy of the new set. So this is the reduced decision tree, and now we calculate the gain of the 3 attributes, which are warm-blooded, fur, and swims. So through this we found that we are finding the gain for attributes warm-blooded, fur, and swim. We find that the gain value for warm-blooded has high. Now we can continue constructing the tree. At this stage all samples are taken case of with single class in each subset. Thus we have obtained this final decision tree as feathers as the root node, and the next decision node is warm-blooded, and we have the leaf node. So this is the final decision tree. So in talking about advantages of decision tree, the first point is inexpensive to construct, and we are extremely fast at classifying unknown records by using this algorithm, which is easy to interpret for small sized trees. This is robust to noise, especially when methods to avoid overfitting are employed, and also it can easily handle redundant or irrelevant attributes unless the attributes are interactive. So talking about disadvantages, the space of possible decision trees is exponentially large. So the greedy approaches are often unable to find the best tree. And also it does not take into account interactions between attributes. And the last one is each decision boundary involves only a single attribute. So that's all talking about ID3 decision tree algorithm. Thank you.